can say, oh, what's the air like there? And the air is pretty much the same age as the snow. And it's older and older and older the further down you go. So if you go to Antarctica and you go to the bottom of the deepest ice in Antarctica, you can find air that's almost 1 million years old, right? It's just like they just got trapped in a bubble and didn't go anywhere for 1 million years. And you can say, okay, well, what was different 1 million years ago? Well, 1 million years ago, there was a lot less carbon dioxide in the air, for a start. This is the last graph. I apologize for this. If you just go back 1,000 years, you can see something very interesting. These are the 3 main greenhouse gases. People will tell you what greenhouse gases are. I'll show you in a second. Carbon dioxide is the most important one. Methane is another important one, N2O. And they were all pretty flat for hundreds of years, right? And if you go back, they were flat for tens of thousands of years before that. And then something happened around 1750. Any idea what that might have been? Yes, us. That's what happened. We discovered that we could burn coal. We discovered how to make agriculture industrialized. And we discovered how to fertilize agriculture. And all of these things have led to these really large changes. Methane has more than doubled. Carbon dioxide has gone up by 40%. Nitrous oxide has gone up by 15%, not as much. But all of these things, on a geological timescale, they're almost vertical. What's a greenhouse gas? Now this is where art really kind of fails us, because that's actually a scientific concept, and we said to the photographers, tell us, show us in an image what a greenhouse gas is. And we said, well, it's kind of like a blanket keeping the earth warm. And I said, oh, okay, put a blanket over there. Which just goes to show you can't explain everything using photography, right? So, but the metaphor is right. Greenhouse gases are like a blanket, and they're keeping the planet much warmer than it otherwise would be. If we didn't have any carbon dioxide, we'd be in a snowball Earth. Everything would be covered in ice. But what we're doing is we're adding levels of blankets. Right? It's not the blankets themselves that are warming us up, but they're just making it so that the Earth doesn't cool as fast, and so it's getting a little sweaty. How do we put all this information together? How do we work out how to deal with the rubber duckies and the ice cores and the dates on the trees? How does that all get synthesized? We use climate models, right, which is what we actually do. This is a very old climate model. We don't use punch cards anymore. And somebody asked me earlier on, what do you program in? And I said, oh, we program in Fortran. This is a line of Fortran from the 1970s. You might remember that. Things have moved on, thankfully. It's a little bit easier now. We have graduate students to put these things in. Each of these things is like one line of code, and this calculates some radiation quantity. And we put all of these things in one at a time. And it would take us a long time to work out anything. Thankfully, computers have got a lot better. But there's a lot of what we've learned from those old climate models that's still valid today. So, like I said, that's an old climate model. That's an old climate modeler. With the printx that we used to have. That was we don't use that anymore. Though we still have a printer just for old time's sake, just to print out for the old bar. But what do they tell us is going to happen, right? This is what I showed you before, right? Up to 2000. Okay, this is the same temperature that you saw, the black line there, and this is what the models suggest. What the uncertainty was going back in time. We do a pretty good job matching everything up until today. And this is what they say will happen if we carry on with business as usual, right? So, and we've got a range of things. We have choices in society, right? So we sometimes get the impression that we don't, that we're just on a path that nothing can stop the path that we're on, but that's not true. We have choices, and the choices that we make will make a difference to what happens in the climate, right? If we try really hard, if we have mitigation, if we try really hard to reduce emissions, we might end up only warming by another degree or so, like maybe 1.5 degrees Fahrenheit. But if we don't do anything, we can end up here. So that's 3, that's 5, 6, 7, 8 degrees Fahrenheit. And what that translates to in temperatures on land is 9, 10 degrees Fahrenheit by the end of the century as a standard increase, right? That's like moving Long Island to Miami, right? That's a huge shift, and a huge shift for the ecosystem, huge shift for the kinds of things that we build. But we don't know everything, right? And this is really important. There are still really important uncertainties in what we know. This is a picture of how we expect rainfall to change, right? So where it's blue and green, we think that the rainfall is going to get larger. Where it's kind of yellows and oranges, we think the rainfall is going to go down, okay? We think that there's going to be more rain up here in the polar regions, more rain and snow, and then less in the kind of the subtropical regions right here. So this is where we live, right? And then there's these dots, right? These dots tell us how confident we are, right? It's a particular thing that we did with all the different models, and this is just a sign of how confident we are. So where there's lots of dots, we were quite confident that that's what's going to happen, right? So we're confident that there's going to be more rain and snow up in the high latitudes. And we're confident there's going to be more rain right in the tropics. But in places like the Sahel in Africa, or in Australia, or in India, or in most of the United States, or in the Amazon, there are no dots. That means that we don't know. That means that we can't tell you with any kind of confidence whether it's going to get wetter or drier. And that's like 2 billion people that we just discussed there. And science right now isn't able to say how they should prepare. Now, it's not that we think that the answer is 0. We don't think the answer is going to be 0 change. But we don't know which of the different scenarios are going to happen because we don't know everything about the system. So there are real uncertainties, right? And we shouldn't think that we know everything. And that's partly why we should not try and go here, because we don't know exactly what's going to happen. This is a picture of the Lake Powell, which is behind the Glen Canyon Dam in the Colorado Basin. This is a reservoir, right? It's not a natural lake. It was built to store water for people downstream of the Colorado. And this bathtub ring that you can see here, that was when the reservoir was full. Now the reservoir hasn't been full since the mid-90s, and there are 2 reasons for that, right? Which goes back to kind of where we started this conversation. One is that it hasn't been raining as much, right? So the American Southwest has been in a multi-year drought situation, and it just isn't raining and it isn't snowing as enough, as much as it used to, and as much as people were expecting. But there's a second reason, right? This is a man-made reservoir, and so we control what the level is by passing off the water to people downstream. And we have been passing off more and more water, right? Because the needs of the people downstream have been increasing year on year on year on year. And so we have 2 things that are going on. We have a natural supply that's going down, and we have a demand that is going up. And these points are crossing. And so that's when it becomes very clear to us that we were expecting climate to do something for us, that climate is deciding not to do anymore. And in fact, not even to keep the same level that it was before, but to actually become less of a service. And so it's this collision between our expectations and the real world that causes the problem. Climate change isn't good or bad, or it's not evil or positive. All of those things are a function of our society, a function of what we anticipate and what we need. And the change is because we're not flexible. We're not resilient to those changes. That's what's good and what's bad. It's the change because of our expectations. Some changes are going to be good. I don't know, some of you may be Long Island wine drinkers. This is a vineyard, not in Long Island, but in the south of England. Not a place known for the quality of its wine. However, it's getting a lot better, which is great for these people. Not so great for the French, but you know, as things go down the toilet, we'll be able to drink a nice glass of English champagne instead of French champagne. So it's not all bad news. Right? But there's surprises. And one of the surprises that, one of the known unknowns, if you like, are some of the feedbacks in the system, some of the amplifying effects in the system. This is a friend of mine, Katie Walter, and what she's doing, this is a lake north of Fairbanks in Alaska, and during the winter time it gets covered in, it freezes and gets covered in snow, and underneath the lake there's all this decaying organic matter, and it produces marsh gas, methane, and it kind of bubbles up and it kind of stays underneath the ice. And if you go up there and you kind of poke a hole in the ice, all that gas wants to come out, and you can set it on fire. There's a great video of Katie on YouTube setting fire to these holes in the ice, and these things just, I mean, they blow up. I mean, it's really very dramatic. The fear is that as the lakes thaw, as more and more of them don't freeze up, that the amount of methane that will be coming out of this is actually going to increase a lot. And methane is one of those greenhouse gases that we're increasing, but it has these natural sources as well. And so that could add to the changes that we're seeing. But we don't know that. We're paying attention to that, but we don't know exactly how that's going to happen. There are other pollutants, right? This is a picture, this is not taken at night. This is a picture taken during the day in China. That's the sun, it's not the moon. China has appalling pollution problems, not just because it's burning carbon dioxide, but because it's doing it very, very inefficiently in the dirtiest ways possible. It's costing hundreds of thousands of people's lives every year. China has this terrible, terrible problem. But the things that will help that are also the things that will help reduce the impact of climate change too. So you've got to think that there are other problems, and you've got to think about solutions that kind of mesh these things together. Of course, you know, some of the problems are political. I'm a federal civil servant, so I really shouldn't be saying anything about this at all, but I'm going to. This is a picture of the Capitol Power Plant, which is the dirtiest power plant in the whole of the DC metro area. And as you can see, it's very close to the Capitol. And it's the reason why it's the dirtiest power plant is because it's controlled solely by Congress. And Congress, because of the power of the coal lobby in Congress, have insisted that this stay a coal-fired power station for years and years and years, way past the time that the EPA said that it should have been shut down and changed to natural gas. That's a real problem, right? There are real vested interests at stake here that don't want anything to change, regardless of how dirty it makes the air or how unlivable it makes the climate. That has to change. Things can change. This is a geothermal power plant in Iceland. We've just seen the solar powers array in Brookhaven. There are new technologies that we can use. Right? This is at Google. This is the Google headquarters. Something like a third of the power for the Google headquarters, not for all their servers, is produced from solar panels on the top of their buildings. This is somewhere close to home as well. You probably don't recognize it, but it's the Fresh Kills landfill. And this is a methane tapping station. So the methane is being generated